Um, so U-substitution, easy way to recognize is if you pick U to be something, whatever derivative that you get at the end must be in the interval. So you could do trial and error, but with good amount of practice, you just know. There are cases where things get tricky. We will do a problem on that later today. But what are the options? I can either pick that, yes, or I could pick that, yes, or I could pick that. Good. 3 candidates. I know what the answer is already, but I'm just doing this for you. If I pick this and took the derivative, am I going to get whatever that's left behind in the integral, which is sine x dx? No. Agreed. Chain rule. E raised cosine x again, and then multiply by sine x. Right? You pretty much end up getting the entire integral back. You go back to where you started. Agreed. One approach. Second one, if you took u to the sine x, du over dx will be cosine. So if I pick that part to be u, whatever that is left behind in the integral is cosine, or should be cosine x. Do I simply have cosine x? No, I have e raised to cosine x. Won't work. That case, if I pick u to be cosine x, du would be negative sine x. Agreed? Key thing to know when you replace by u 2 conditions, or the second condition being the entire integral must be transformed in terms of u. If that happens, we're happy. Here, I'm not picking all of that to be u. That case, that will work, but there's a trick to it. I don't want to get into it. So I'm not picking the entire thing. I'm just picking that. But I know how to find the integral of e raised x. That's why I said bring the table of integrals. So if that becomes u, whatever that is left behind in terms of x has to be sine x dx. Yes? Do we have that bit over there? Yes? If I rewrite du over dx, I'll get negative sine x. Du would be negative sine x dx. But I want sine x dx. What should I do?
You could put the negative sign in front.
Move the negative this side. So negative du would be sine x dx. So entire part becomes negative du. Negative is just negative 1. I can pull that out of the integral. Negative comes out. What is the integral of e raised to u? E raised to u. Are we done yet? No. Some Students tend to put plus C right here. I'll wait until the very last step and then put that plus C. The best way to do it, once everything is done, you add plus C at the very last step. So, going to replace U by cosine. Am I done yet? No. Good. Any questions before? No? Okay. Integral ln of x squared divided by x multiplied by dx. Anytime you have logarithms, I cannot stress this enough. When you have logarithms, try to use properties of logarithms first. Then you can go on and try to integrate. That is the best way. Is there a property of logarithms that comes to your mind in this case? Calculus 1. Alex? No, what's his name?
Can't you just
What's your name?
subtract them?
What's your-
Jordan?
Jordan. Subtract.
Am I wrong?
Yes.
Isn't any derivative of log of something just 1 above x?
True, but I can't do it directly. I got to do something.
Can't you put the 2 out in the front?
Can't I? can't, absolutely. So, if you have logarithm of some term with the power, a term by itself, you can move the power up. Yes? Anytime you have logarithms, that should be your first step. So 2 ln of x divided by x dx. Pull the 2 out. J, right? This is what he was referring to. At this step, you should know what U is. If you pick the right U, you would be able to convert that integral to something purely in terms of U. So what should U be? Options. You can either pick U to be 1 over x. Yes, that's one function. You could pick U to be ln of x, another function. Of the two, which one will work? This the derivative of 1 over x is negative 1 over x squared. Derivative of u, which is ln of x. What do we get? 1 over x. 1 over x. So if I picked 1 over x to be u, whatever that remains in the integral must be negative 1 over x squared. That is not the case. Still have that logarithm lingering. But if I picked that to be u, I end up getting 1 over x, the other part of the integral. So of the two choices, it has to be that one. So we have the 2 outside the integral, u times, rewrite that, du would be 1 over x times dx. Dx divided by x, and wrote it as dx divided by x. Those two are one and the same. So 2 integral u times du. Did I successfully convert the integral from x to u entirely? I did. What is the integral of that?
U squared root 2. Let's see.
You can put it now, but I'll wait until later. What is one more step that's left?
We substitute back in.
I've got to substitute back. I have ln of x squared plus c. Before we move on, I'm going to ask a question now. Let's see if you can give me the correct answer. Okay. That is our answer. Is it okay for me to say, use the power rule again, move it over here, right here? No. Caitlin? No, Catherine?
First one.
Caitlin, okay. So you're saying no, why not?
I don't quite remember, but I feel like it has to be attached to the thing.
Do you hear what Caitlin said? No. Louder, Caitlin.
Is it right?
It is.
Okay. The exponent has to be attached to whatever is in the parentheses of the natural law.
Very good. So, if this 2 were to be inside here, I can pull it up. So, no matter what the expression is, you could have a huge expression, x cubed plus x plus 1. The only way you could pull a power out is if this entire expression is raised to, say, power of 3. Then you can pull the 3 out. Good? But this is not the same as that. Good? This is what resulted in that, but those two are not the same. Good? So don't make that mistake. It's a common mistake.
It's work.
So things to remember in this problem. You pick something as you, whatever that's left behind should be D. One way to look at it, another way, you have some function, and there is some other function that came into that function. That explanation is rather complicated. So you can do trial and error. You can either pick u to be cosine root x entirely, correct? Or you could pick u to be 1 over 3 root x. Yes. Or you could pick simply root x. Those are my options. Again, with good amount of practice, unless it's a trick question, you should be able to figure this out. There are a couple of questions where you have to do a transformation. We will get into that. So I've got 3 choices. Some of you identified the right one. Good job. If you didn't, practice more. Case 1. What is the derivative of cosine root x? What rule should we use? Let's start there. change function within a function. So if I did du over dx, I should get negative sine root x and something else. I'll just leave it at this. Okay, created some space here for a reason. So let's start transforming that integral. So I picked u to be cosine root x. So u, good. Divided by 3 root x dx. Yes, that entire bit needs to show up in my derivative. Agreed. Does this show up in my derivative? Yes or no? It doesn't. So that can't be it. Next, if I rewrite the integral, I'll have cosine root x times dx over 3 root x. Just rewriting it. I'm calling u to be 1 over 3 root x. Well, I'm doing this extra step so that you can understand that, they are the same. Oh, sorry, that, and that, they're all the same. Agreed. I'm just doing the denominator.
You're the square root x in the cosine.
Oh, I see. Now they are the same. Okay, if I pick u to be this part and take its derivative, is there any way possible while you take the derivative of 1 over 3 root x and you end up getting cosine? It is not possible. The only way the derivative would even have a cosine for any function is if you had a trigonometric function of some sort. Yes, some trigonometric function. That is not what gone. Leaves us with one last option. If you don't have it in your table of integrals, do put this. I've seen students miss this in part 3 differential calculus 4000 courses. The derivative of root x is 1 over 2 root x. Might wonder, how did I get that? Any thoughts?
Square root of x can also be written as x to the 1/2 power. Break it down.
And then it's the usual differentiation process. 1/2 times x raised 1/2 minus 1, negative 1/2. Rewrite it back in the radical. You'll get this. Make sure you put that in your cheat sheet. Or table of integrals. Okay. Let's see if choosing root x to be u ends up giving du somewhere over here. Well, I'm going to pull 3 out. Cosine root x times 1 over root x times dx. Yes? I don't have that entire thing over here, but I'm close. Yes? What am I missing? Here. If I had something here, that one and that one would match up.
2.
2. Awesome. So how do I magically get a 2 here? Just that. Life doesn't work that way.
Should.
How do I get that 2?
You put 2/3 instead of 1/3 as the coefficient on the side.
True, but what process did you use, Michael, to get that 2/3 distribution? Edward? No, what's your name?
Michael.
Michael, okay. Michael number 2. Did you have an answer?
Well, I was gonna say the sampling needed, you have to bring it out.
Yeah, so bring what out?
That's good.
2. You mean here?
Yes.
Okay. Do you follow my question? I am getting du to be 1/2 root x dx. Yes. 2 ways to approach this. If I'm understanding the Michaels correctly, not just all, Michael 1 and Michael 2, they want to bring 2 to that side. Is that what you're suggesting? Or no? You could say no.
I'm not sure if I follow.
So you said it has to be 2 pairs somewhere here, correct? My question is, where did you get that 2 from? What did you do? Okay. Do we understand this part? Yes? Michael?
Since your du over dx is 1/2 times the square root, and you don't have the 2 in the denominator, you have to multiply by 2 to get it out.
So how do I get that 2? What trick should I use? That's my question. Jake?
Because there's a 2 in the denominator, you just multiply the fraction by 2, then bring it over to the du. On the,
Okay, so you are saying multiply both sides by 2?
Yep.
Okay. Option 1. So 2 times du would be 1/root x dx. Good? That is the approach that I like. But if you're not comfortable with this, and you just want a 2 there, you can't simply put a 2. You have to multiply and divide by 2. You're not doing anything wrong algebraically, are you? No. So multiply, divide by 2, you end up getting 2 x. That's there. Good. It is a matter of choice. I personally like this way. Which one do you prefer? That or that? This is the better way. So all this is would become 2 du. That would become u. Did I successfully convert the integral in terms of x to an integral in terms of u? I can pull the 2 out. So 2/3 integral cosine u du. What is the integral of cosine u? Negative sine u.
Oh, sorry.
Common mistake. When I first learned it, I made that mistake too. It's just sine. Good. Yes, no, maybe. Replace u and plus c. Good. So I'm doing trial and error these extra steps so that you can follow what's happening. Good amount of practice, you will be able to spot you right away. If the integral can be integrated, using U-Substitution. Clear? Okay. Let's try one more. You are going to try. What is it? What are you doing? X squared times x cubed minus 2, entire thing raised to 2 over 3 times dx. Let's see if we can find the appropriate u first. Once you identify that, things will go smoothly. Hopefully. Use your table of integrals if need be. Always comes down to picking the right substitution. So here I see x cubed and a constant. The derivative of x cubed is 3x squared. So immediately my eyes and my brain is looking at this and knows, okay, u has to be x cubed. Because when I take the derivative, I get it x squared. However, got that negative 2 hovering around. Yes, this is where you need to have, another trick in your mind. Derivative of negative 2 is 0. Yes, so that negative 2 is going to go away. So if I pick that entire term as u, right, du over dx, derivative of x cubed is 3x squared. Derivative of negative 2 is 0, so I don't have to put that there. Du would be 3x squared dx. Good. So far, so good. Now, algebra. Lorenzo asked me, well, it seems easier to me that I just divide by 3x squared and put that in here. Never combine u's with x's when you write it. In this case, it might be easier, but as you go, cut 2, cut 3 and other stuff, switching variables, never a good idea when you carry them. Just have to transform everything to one variable before you move on. That is the right approach. So this becomes u raised to over 3, correct? What do I leave behind the moment I make that substitution? I have x squared dx, correct? Over here, I don't have x squared dx. I have 3x squared dx. How do I solve for x squared dx? Divide by 3 on both sides. So du over 3 would be x squared dx. So once that substitution is made, whatever that is behind in the integral would be x squared dx. Yes? So I can replace all of x squared dx by du divided by 3. Good. Pull the constant out. 1 over 3. U raised 2 over 3 du. That is easy to integrate. Do we agree? Easy cake. Hopefully. Erase. What is the integral of that? U raised 5/3 divided by 5/3. Flip and multiply. This is where some of you make mistakes. Algebra, important. 1/3 times 3/5 times U raised 5/3. Goes away. 1/5 U raised 5/3. Are we done? No, we've got to substitute back. 1/5 x cubed minus 2 raised 5/3. Are we done?
You have to plus it.
Plus the. Now we are done. Good. Okay, then there is a difference between this problem and that problem. Can someone spot the difference? Crucial difference. Don't tell me, oh, there is an 8. This is in blue, that's in black. Crucial difference.
Isn't that the inside term? The exponent is less than the outside term.
If you look at that one, the exponent here inside the radical expression is bigger than the one outside. So over here, whatever you have inside, the exponent that you have inside the radical is less than that. Yes? Last problem, things worked out nicely. You know, kind of. So you do a problem like that and your brain says, oh, why don't we just pick u to be x squared plus 16 and go from there? Yes, rational thought process. So what is du over dx?
2x.
2x. And we always like to have x terms on one side, use constants on the other, multiply by dx on both sides. Du is 2x dx. Move that 1/2, move that to this side. You have 1/2 du x dx. And so far, this is not trial and error. Rather, I'm going along with the same logic that I used to the previous problem. Do you agree? But because of the switch in exponents, I have a problem. Huge problem. What is that problem? If I picked u to the square root of x squared plus 16, this becomes root u. I can pull a out. That's not a problem. So once that substitution is made, whatever that's behind or whatever that you leave behind in the interval is x cubed times dx. Correct? All I have is x times dx. Painful, correct? What's your name?
Alex.
Alex. Alex had an idea, which is natural, you know, but if life was that easy, I would be in a different galaxy. It's a natural thing. I know some of you thought of this. So Alex looked at this cube. Cube is missing, so let's cube on both sides, make ourselves an easy choice. But what Alex forgot, when I cubed, it's not just x that will get cubed, but the dx will also get cubed. But aside from that algebraic issue, this is something that we cannot do. It defeats the meaning and purpose of derivatives. You can't do this. That said, Alex now doesn't know what to do. Any thoughts? Do we see the predicament that we are in? Last problem, things worked out nicely. This one is giving us trouble. Lorenzo?
Software execution.
Very good. Solve for x cubed? How would I do that?
Subtract 16 from the.
But that is not cube, that's a square.
Or square, yeah.
Okay, so Lorenzo says, let's solve for x squared. Since u is x squared plus 16, x squared will be u minus 16. Agreed? So why did Lorenzo solve for x squared? Lorenzo is going to give us the answer. Go ahead.
So you get everything in terms of u.
So I can get everything in terms of u. Well, that doesn't make any sense because I have an x cubed. You're solving for x squared.
So you substitute the x squared that you would have got for u minus 16.
Okay, I see. Kind of accept your explanation, but I see this process. This is the correct thought process. Now that I'm here, why did Lorenzo pick this approach of solving for x squared? The derivative part gave you x dx. Yes, went along with the previous problem's logic. So I am getting x dx. So it's best I just keep it. Agreed? If I took an x from x cubed and put it over here, x dx, yes? What will be there?
X squared. X squared.
Alison says x squared. Do we agree with Alison? Yeah. Okay. We already know x dx is 1/2 du. Great. Lorenzo suggested that we solve for x squared. Great. So what was in terms of x now became integral u minus 16 times root u times 1/2 du. Did I say x? No, there is no x here. Did I successfully convert the integral that was in terms of x to an integral in terms of u? Yes or no? Yes. So that integral is a u minus 16 times root u times 1/2 du. That's what I read aloud. Now, bring that 1/2 out of the integral. 8 divided by 2 u minus 16 times root u d. Good. So I started with this because sometimes you've got to do a bit of algebra to be successful. Later, when we get to technology substitution, you've got options. And at that time, you can ask yourself, well, should I do it this way or that way? You make a choice. One would be easier than the other for sure. Let's see. 8/2 is 4. Great. What to do about that? Abort mission. Okay. to the beginning of class. Anytime you see logarithms, what should you do?
Use their properties.
Use the property. Can't forget until the end of this semester. You cannot forget until the end of your scientific career. Alice, we're about to say something.
I was gonna say, like, get the square root get you out of the square root symbol.
How do we do that?
Could,
It's
write
great.
u over 1/2.
Okay, very good. Just like that first thing I said at the beginning of class, anytime you see logarithms, you use properties of logarithms. Anytime you see radicals, immediately your brain should associate it with exponents, fractional exponents. Good. Start that habit. At this point, things are easy. If I distribute u raised 1/2 in here, what is u times u raised 1/2?
2u, 1/4.
2u.
Show you 3/2.
U raised 3/2. Bases are the same as the exponents, properties of exponents. This part is easy. What is 16 times u raised 1/2?
16 over 2.
Okay, 16 u raised 1/2. We know that we can distribute that integral because I just have terms in addition. So going to keep that 4 outside and integrate the first term. What is the integral of u raised 3/2?
5/2 over 5/2.
U raised 5/2 divided by 5/2, which is the same as 2/5 u raised 5/2. What is the derivative of integral of u raised 1/2?
U 3/2 over 3/2.
U raised 3/2 divided by 3/2, which is 2/3 u raised 3/2. Good. Have we simplified something here? There isn't much that I can do. I have a 2 in common. I can pull out here, 2 there, becomes 8. U raised 5/2/5 minus u raised 3/2/3. Plug in u back. What is u? X squared plus 16.
Where'd the 16 go on the second step from the top? You wrote
Just
u.
vanished, right? Okay, thank you.
Okay.
16.
I'm just like, where'd
Forgot
it go?
that 16. There is another common factor in the numerator between the first 2 terms. Can you spot that common factor? Just like I pulled 2 out, there is another factor. Raised 3/2. I can write 5/2 as this term multiplied by x squared plus 16. I didn't take it that far because either way, it is a complicated, funny looking answer, correct? So that's good enough. I wouldn't go and try to simplify it unless I know that it is going to simplify nicely. When you do the homework though, not the same. If you use flip sign, you'll learn. they want you to understand. So key things to know. One, trick. So if you are getting part of the integral, but you were able to rewrite the other part in terms of x, excuse me, in terms of u by doing a trick, use that algebraic trick. Two, anytime you have radicals, you should know that you rewrite it in terms of exponents, then you'll know what to do. Okay? And do note the difference between this problem and that one.